Good morning, children. Today's topic is geometrical meaning of zeros of a polynomial. A linear polynomial ax plus b will always have a straight line as a graph in the coordinate system. If you observe this straight line, the graph intersects the x-axis at exactly one point. That is, the graph of a linear polynomial ax plus b will be a straight line and it intersects the x-axis at exactly one point. The graph of a quadratic polynomial ax square plus bx plus c is called as a parabola, and case 1, if you observe, this parabola intersects the x-axis at 2 points. This parabola intersects the x-axis at 1 point, and this parabola do not intersect the x-axis at all. Thus, a quadratic polynomial of the form ax square plus bx plus c is represented by a parabola, and the number of zeros for a quadratic polynomial is either 2 or 1 or 0. The example of a quadratic polynomial which do not have a 0 is x square plus 2. By algebraic method, x square plus 2 is equal to 0, x square is equal to minus 2, or the value of x is square root of minus 2, which do not belong to the system of real numbers. The value of x can be found out by using the system of complex numbers, which is a syllabus of class 11. Thus, from these graphs, what can you infer about the zeros of a polynomial? That is, how many zeros will be there for a polynomial, or what will be the value of those zeros? By looking into the graph, you can see the graph meeting the or intersecting the x-axis at one point, which shows that there is one solution. When a graph intersects the x-axis at 2 points, it has two solutions. Or when a graph is intersecting the x-axis at 3 points, it has 3 zeros. Thus, in general, if a graph is given to you, you can check the number of points where the graph intersects the x-axis, which will give you the number of zeros, and the x-coordinate of the point will give you the value of the zeros. By looking here, you can see the value of x is 2. Here, the two values are minus 1 and plus 1. Here also the value of x is equal to 2. Here also the value of x is minus 2, 0 and 2. Thus, in general, the zeros of a polynomial is those value of the x coordinate where the points meet the x-axis. Similar questions can be practiced from example 1 of page number 27 and exercise 1 2.1 page number 28, exercise 2.1 question number 1. The next topic in today's class is relationship between zeros and coefficients of a polynomial. A linear polynomial ax plus b, the zero can be found out using the method ax plus b equal to 0, ax is equal to minus b or x is equal to minus b by a. What is this b? B represents the constant value in the polynomial and a represent the coefficient of x. That is, the rule is minus of constant by the coefficient of x. That is the relation between the 0 and the coefficient of a polynomial in the case of a linear polynomial. Consider x square minus 5x plus 6 as a quadratic polynomial. By splitting of middle term, product is equal to plus 6, sum is equal to minus 5. The factors of 6 are 2 and 3. As per the rule, when the product is positive, according to the sign of the sum, both factors will have the same sign. You will factorize as x square minus 2x minus 3x plus 6, x into x minus 2 minus 3 and 6 common factor is 3, x minus 2, x minus 2 into x minus 3 are the factors. The zeros are x minus 2 equal to 0, x is the value 2, x minus 3 equal to 0, which shows that x equal to 3. Thus, the two zeros of this quadratic polynomial is 2 and 3. Let us call them as alpha and beta. Let alpha is equal to 2 and beta is equal to 3. What is the sum of the zeros? The sum of the zeros is alpha plus beta, which is the same as 2 plus 3, which is equal to 5. What is the product of the zeros? The product of the zeros is alpha into beta, which is equal to 2 into 3, which is equal to 6. You got the sum of zeros as 5 and the product of the zeros as 6. Compare the given quadratic polynomial with the general form of the quadratic polynomial. Once you compare it, you will get the value of a as 1. Compare the coefficients. The value of a is 1. The value of b is minus 5 and the value of c is 6. Find out what is the value for minus b by a. Your b represents minus 5. Therefore, minus b by a is minus of minus 5 by 1, which is equal to positive 5. Find what is the value of c by a. C represents 6 by 1, which is equal to 6. Once you see here, the sum of the zeros is giving you 5. Product of the zeros is giving you 6. The same way, minus b by a value is also 5. C by a value is also 6. Thus, the rule or the relation is alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. That is, if c by a. That is, if alpha and beta represents the two zeros of a quadratic polynomial, sum of the zeros alpha plus beta is equal to minus b by a and product of the zeros alpha into beta is equal to c by a. Let me explain one more example. to make you understand the relation between the zeros and coefficients very clearly. The polynomial 2x square minus 8x plus 6. Product is equal to 12 and sum is equal to minus 8. The factors of 12 which gives a sum of minus 8 is minus 2 and minus 6. 2x square minus 2x minus 6x plus 6. The common factor 2x into x minus 1 minus 6 into x minus 1. 2x minus 6 into x minus 1 are the factors. The zeros are 2x minus 6 equal to 0, x is equal to 6 by 2, 3. X minus 1 equal to 0, x is equal to 1. Let us call the zeros as alpha is equal to 3, beta is equal to 1. Sum of zeros is alpha plus beta, which is equal to 3 plus 1, which is equal to 4. The product of zeros equal to alpha into beta is the same as 3 into 1, which is equal to 3. The polynomial 2x square minus 8x plus 6, when compared with the general form of ax square plus bx plus c, have the values of a as 2, b as minus 8 and c as 6. The value for minus b by a is the same as minus of minus 8 by 2, 8 by 2, which is equal to 4. And the value of c by a is the same as 6 by 2, which is equal to 3. Thus you can see here also alpha plus beta is equal to minus b by a and alpha beta is equal to c by a is verified. Alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. This is the relation between the zeros and the coefficient of a polynomial. That is, the sum of the zeros is equal to minus of coefficient of x by the coefficient of x square, and product of zeros is equal to constant by the coefficient of x square term. So what will be the relation between the zeros and coefficients of a cubic polynomial? It is an extension of linear polynomial and quadratic polynomial. A cubic polynomial can have a maximum of 3 zeros. Let us call them as alpha, beta and gamma. There are three relationships regarding the value of the zeros and the coefficient. The first rule is the sum of the zeros alpha plus beta plus gamma will be minus b by a, the same way as minus coefficient of x square by the coefficient of x cube. The second rule is the sum of product of two zeros taken at a time. Once again, the sum of product of two zeros taken at a time. The first two zeros alpha, beta, their product. The next two zeros beta, gamma, their product. And the first and the third zero alpha, gamma. This is the second rule. Alpha, beta, beta, gamma plus alpha, gamma is the same as c by a. That is the coefficient of x by the coefficient of x cube. And the third rule of Product of the zeros, alpha, beta, gamma is equal to minus d by a, that is the constant term by the coefficient of x cube. For a cubic polynomial, if alpha, beta, gamma represents the three zeros, alpha plus beta plus gamma is the same as minus b by a. Alpha beta plus beta gamma plus alpha gamma is equal to c by a, and alpha beta gamma, the product is equal to minus d by a.